I'm Saranya, going to teach electromagnetic theory subject. In this subject, we are going to study about sources and effects of electromagnetic field, Unit 1. So this is for EMF, electromagnetic field. What are the sources of electromagnetic field? In our home, we are using home appliances. So each and every appliances have some electromagnetic field, like jacket, fridge, washing machine, whatever we have, everything. You have to take even mobile phones, TV, everything will have electromagnetic fields. So here electrical power supply and appliances are the most common sources of low frequency electric and magnetic fields in our living environment. Everyday sources of radio frequency electromagnetic fields are telecommunication, broadcasting, antennas and microwave ovens. So here we are using jacket. Jacket will have low frequency EMF. We can't see the electromagnetic field, but we can feel the electromagnetic field. Like if you are watching TV for a long time, you will get some eye irritation, headache, even some sleeping disorder, lack of concentration. So many problems you will face because of this electromagnetic fields. So everyday source of radio frequency electromagnetic fields are telecommunication, broadcasting, antenna and microwave ovens. Then the electromagnetic spectrum includes from longest wavelength to shortest wavelength, radio waves, microwaves, infrared, optical, ultraviolet, X-rays and gamma rays. This is for electromagnetism. Electromagnetism is one of the fundamental phenomena in nature. It is responsible for almost all the phenomena in our daily life. Gauss law in electrostatics, Gauss law in magnetostatics also we are using so far. Then Ampere's law and Faraday's law. Ampere's law, Faraday's law, and one more law we will use, Coulomb's law. Last one is Maxwell's equation, pointing theorem. So these are the things we are going to study in electromagnetic fields. So these laws were combined by James Clerk Maxwell in the year 1864. So this electromagnetic field started from Maxwell's equation only. If you are using any communications like satellite communication, microwave, any communication if you are using, means first you have to take the wave. Okay, so the wave means we will take electromagnetic wave. So for electromagnetic wave we will study about generation. So electromagnetic wave generation means we are going to write the equation. So the equation will starting from Maxwell's. So Maxwell's equation we will have four Maxwell's equation. So from the Maxwell's equation we can get the wave equation. So these laws are combined by James Clerk Maxwell in the year 1864 to give a complete set of relation and connection between both the forces of electricity and magnetism. So Maxwell only the reason for this electromagnetic wave generation. So here we will get equations for electromagnetic wave, electromagnetic wave, electric field, magnetic field. So many equations we will be getting in this subject. It is basically from Maxwell's. So the Maxwell's also derived from Gauss law, Ampere's law, Faraday's law and so many laws. So he has referred these laws and created some equation is called Maxwell's equation. From the Maxwell's equation they have generated equations is called wave equation for electric field and magnetic field, which is the main thing we are using it in communications. So this for electromagnetic field, EMF or EM field is a physical field produced by moving electrically charged objects. The field can be viewed as the combination of electric field and a magnetic field. The electric field is produced by stationary charges and the magnetic field is produced by moving charges like currents. If current is flowing through the coil, magnetic field is produced around the coil. So we have studied about this. So current carrying conductor. So around the conductor we will get magnetic field. So the two are often described as the sources of field. So electric field and magnetic field will be created. Electric field is produced by stationary charges and magnetic field is produced by moving charges. So these are often described by the sources of electric source of field. So here we have a coil. The next one is electromagnetic field at home. Electricity is transmitted over long distance via high voltage power line. Electricity transmission and distribution facilities and residential wiring and appliances account for the background level of power frequency, electric and magnetic field in the home. So this is for electric field, electromagnetic field at home. This one for electromagnetic field at home. So here electricity is transmitted over long distance via high voltage power lines. Electricity transmission and distribution facility, residential wiring, appliances. Level of frequency will vary. If you take jacket, it will have low frequency EMF. Like mobile phones, radio, TV, everything will have some frequency. So this is for low frequency field. Low frequency field jacket, power jacket. Then radio frequency. Then visible light. X-rays and Y-rays, ionizing radiation. So here ionizing radiation, here ionizing. So here this is for low frequency field, radio frequency, visible light, X-rays and Y-rays. So some examples: power jacket, laptop, tower. Here we are having radio frequency, radio, TV, mobile phones and satellite antenna. So next one is visible light, infrared, ultraviolet, X-rays and Y-rays. So this is for frequency in hertz. So according to this frequency only we will get low frequency, radio frequency, visible light and X-rays. So symptoms of EMF exposure I already said. If you are watching TV for continuous, if you are watching TV, or if you are using mobile phone continuously, means you will get some irritation. After some time you may feel some sleeping disorder. So that is called, here is sleep disturbance, headache, depression and depressive symptoms. Then tiredness, lack of concentration, changes in memory, dizziness. So these are the symptoms of EMF exposure. So we can't see the electromagnetic field, but we can feel the electromagnetic field. By this type of symptoms we will get it. So the electric field is produced by stationary charges and the magnetic field produced by moving charges. So we will get source of field. The way in which charges and currents interact with the electromagnetic field is described by Maxwell's equation and the Lorentz force law. So Lorentz force means which is combined both the stationary charges and moving charges. So it will create the force. The sum of these two forces is called Lorentz force. So we will get this Lorentz force equation in forthcoming units. So how do you stop electromagnetic fields? Electromagnetic shielding is the process of lowering the electromagnetic field in an area by barricading it with conductive or magnetic material. Copper is used for RF shielding. So here we have to stop the electromagnetic field. So we know the symptoms of EMF exposure already. So we have to do some screening with the help of copper material. Then only we can shield the electromagnetic field for better life. So how much frequency is harmful for humans? The most restrictive limits on whole body exposure are in the range of 30 to 300 megahertz, where the human body absorbs RF energy most efficiently when the whole body is exposed. Radio waves are a type of electromagnetic radiation with wavelength in the electromagnetic spectrum longer than infrared light. So, source of electromagnetic topic is over. Now we are going to study about vector fields. So in vector field, we are going to study about vector addition, subtraction, multiplication. So we in this unit the important topic means we have to study about only multiplication. Okay. So in scalar and scalar means scalar is characterized by its magnitude. Just we will have some value means scalar. If you take vector, vector is characterized by its magnitude and direction. So magnitude and direction means if simply number is written means it will be read as some numbers 7, 8 means that is called scalar. If 7x vector, 7y vector, so the 7 is magnitude, that x or y is in direction. So x, y, z coordinate system, x 3 dimension. If you take x, y, z, so here we have to know the direction means vector. So for vector we will use velocity, force, momentum. Like scalar, voltage, current, energy, temperature, whatever we are using without any direction, just number. Okay, so that is called scalar field. So which is indicated by only simple line. Vector is indicated by arrow. So here vector calculus addition. Here we have written A and B. So here A, B. So here A plus B. So here we have to study about vector calculus. In vector calculus we will have addition, subtraction, multiplication. Multiplication means cross product and dot product. So in vector calculus addition we will have A, B. So A plus B is A plus B. Like addition we will have A minus B. So A plus B plus C associative law, A plus B plus C. Likewise distributive law. So next one is for vector field. Fluid flow associated with the source. Circulating flow of particles. This is for vector field. So vector is characterized by its magnitude and direction. So quantities that have no direction associated with them are called scalar quantities. In contrast, vector quantity has both the magnitude and direction. The vector quantity can be represented by an arrow drawn to scale. So just we will draw arrow for vector field. So dot product means we will write A is one vector, B is another vector. So it can be multiplied. So we will get dot product A dot B is equal to AB cos theta. So A dot B equal to AB cos theta. A we have to take in mod A, that is called magnitude of A, magnitude of B, and cos theta. Theta angle between the vector A and B. So here we have two vectors. So this is for dot for dot product or scalar product. So the product of magnitude of AB and cosine of the smaller angle between them. So we will get A dot B equal to AB cos theta. So some examples of vector field. Magnetic field of a bar magnet. So the needle aligns itself along with the direction of magnetic field. That magnetic field begins as if there were a bar magnet in it. This is for examples of vector field. So next one is dot product. Dot product of two vectors A and B is defined as the scalar value. A dot B is equal to AB cos theta. Theta is the angle between A and B. So angle it may vary from 0 to pi. So this for dot product. The next one is A dot B is equal to AB cos theta. Formula for dot product. So this for history of dot product. if you take a vector, vector A is equal to A1i plus A2j plus A3k. It may be used as ijk or xyz. If you refer some other books, it may be written ax, ay, az in the place of ijk. So you may use ijk or xyz or ax, ay, az. You can refer anyone for vectors. So this for direction ijk. So ax, ay, az. The angular relationship of two vectors a dot b is equal to ab cos theta. So simply we have written ab cos theta. While writing you have to take mod a, that means magnitude of a, magnitude of b. So here dot product a is equal to ax, ax, ay, az, az. Likewise b, bx, ax, by, ay, bz, az. So a dot b means just to multiply these things. Ax equal to 1, ay is equal to 1, az equal to 1. So if you multiply the same thing, you will get 1. So here we have written for ax equal to 1, ay equal to 1, and az equal to 1. So here xy, yz, xz equal to 0. If you multiply alternate xy, yz, az, x also 0. So you can write 0 for this. So you can write ax, bx, ay, by, az, bz. So these things are ax equal to 1, ay equal to 1, az equal to 1. This is for dot product. So this is for dot product. Here ax is given, likewise ijk also given. So you may take ijk or ax, ay, az or simply xyz also. All are same. So you can use any one for vector. So if you multiply alternate things, you will get 0. The same thing will be multiplied, then you will get 1. Okay, the next one is cross product. So this is also one of the multiplication for vector. So y cross product, the accumulation of interaction between two different dimensions. Like here, a, b, two vectors, ai, aj, ak, bi, bj, bk. Here we have written 1, 2, 3 and b1, b2, b3. So now we are going to write in matrix. For matrix A cross B, just we have to write ijk for vector ijk. Then the coefficient of I is A1. Here we have to write A1. Like coefficient of J is A2. Then coefficient of K is A3. So here also we have to take coefficient of I is B1, J is B2, K is B3. So we have written these things for A1, A2, A3, B1, B2, B3. So now we can multiply like a matrix. If you want to get I, you have to multiply this A2 and B3, A3, B2. Okay. Then for J, minus J. So we have to take only, if you want to write I, then you have to leave this row and column just to multiply these things. So if you want to get J, you have to leave this row and this column. Likewise K, then this row and this column. So these things will be multiplied like matrix. So here we have to get the answer for cross product. Then cross product A dot B equal to AB sin theta. So mod A, mod B and sin theta we will take. So angle between the vectors, we can calculate angle between the vector by using A dot B equal to AB cos theta or A cross B equal to AB sin theta. So theta is the angle between the two vectors. It can be calculated by using either cos theta or sin theta. So we may use any one formula for this. So here A cross product A cross B equal to AB sin theta. So this is for cross product explanation. So here we are going to write A cross B. So for A cross B, we can write AX, BX, AX cross AX. If you multiply same thing in cross product, you will get 0. So if you multiply alternate things, like if you multiply with X and Y, you will get Z is answer. Like Y and Z, you will get X is answer. Then X and Z you multiply, then you will get Y as the answer. So you have to take alternate things will be multiplied, you will get another one answer for cross product. If you multiply the same thing you will get 0. Okay, so we have to substitute these things in cross product, then we will get this matrix. So Ax, Ay, Az and Bx, By, Bz in matrix form. Now we have to multiply, then we will get the answer. So the application of vectors where we were using means sports. Okay, sports and some other applications, like wherever you are using direction, so you will be using this vector fields. So next one is divergence. Divergence in vector calculus, divergence is a vector operator. So we will have three types of operator. One is divergence, another one is curl, another one is gradient. So divergence is a vector operator that measures the magnitude of a vector field, source or sink at a point in terms of signed scalar. More technically, the divergence represents the volume density of a outward flux of a vector field from an infinitesimal volume around a given point. So this is for divergence definition. So the divergence is a vector operator. So divergence F is equal to Pi plus Qj plus Rk is a vector field on dou P by dou X, dou Q by dou Y, dou R by dou Z. So divergence means just we have to write divergence of F dou by dou X, dou by dou Y, dou by dou Z, whatever is given in I, J, K. So here we will write P, Q, the coefficient of I is P, coefficient of J is Q, coefficient of K is R. So we have to write this divergence of S equal to dou P by dou X, dou Q by dou Y and dou R by dou Z. Just write div F for divergence. Sometimes it may be written as del dot, that is also called divergence. So here we have written divergence E or del dot A, both are same. So limit del V tends to 0, here A dot ds equal A dot ds divided by del V. This is for divergence equation. So you have to write this equation, divergence of F and del dot A, this equation for divergence. So divergence of a vector means here we have written A dot ds. Ds means surface area. So surface area, here we will take integral A dot ds. This is for volume, unit volume. This limit del V tends to 0. So vector field A at closed surface. So A dot ds equal to, so front, back, left, right, top and bottom. So we will get 6 equations for A dot ds. V is the volume enclosed by surface. So next one is divergence theorem. It states that total outward flux of a vector A at the closed surface is the same as volume integral of divergence A del dot A. So del dot A dot ds equal to del dot A dV. So next one, for divergence we have written the equation. Just we have to substitute del means dou by dou X I, dou by dou Y J, dou by dou Z K. So dou by dou X I, dou by dou Y J and dou by dou Z K. This is for divergence. So divergence of F means just to multiply with F. So we have to take dou F by dou X. Some equations will be given, just substitute for I, coefficient of J and K for divergence. So here we are going to see divergence of A. So A is equal to x square y I minus xyz j plus yz square k. Determine divergence A at point 1, 2, 3. So divergence A is equal to del dot A. Here dou by dou X I, dou by dou Y J, dou by dou Z K is given. Then we will take for A, AI, AX, AY, AZ. So just to multiply these things, you will get dou AX by dou X, dou AY by dou Y, dou AZ by dou Z. So this is for divergence of A. Now we can substitute this coefficient x square y in the place of AX. So just to multiply x square y here, then minus xyz plus yz square. So you have to differentiate once. You will get 2xy in the place of dou ax by x. So we have differentiated once, we will get 2xy. Likewise here we have to differentiate with respect to y, then we will get minus xz. So, okay, so minus xyz can be written as minus xz. Okay. The next step, yz square. So you may take y as it is, then z square. Differentiate with respect to z, we will get 2z. So you can substitute 2xy minus xz plus 2yz. Now we are going to substitute the limits 1, 2, 3. 1, 2, 3 in this this answer. So you will get 1, 2, 3. Okay. So 2, 1, 2, 1, 3, 2, 1, 3. Okay. So now we will get the answer. 2 into 2, 4 minus 3 plus 12. So we will get 13 as the answer for divergence of A. So divergence of A means we have to take just dou by dou xi, dou by dou yj, dou by dou zk. So we have to write this equation and simply multiply, then differentiate with respect to x, y, z. So we will get divergence of A is equal to 2xy minus xz plus 2yz. So now we are going to substitute we are going to substitute 1, 2, 3 in this equation. We will get 2, 1, 2 minus 1, 3, 2, 2, 3. So divergence 13. So likewise, if ijk, instead of ijk, it may be written as ax or ax, whatever is given with the vector or cap, something will be written ijk or xyz. So we have to take it as a, whatever is given, just multiply and differentiate and find the answer for this.